This is a collaboration video with Real Life Lore. Be sure to follow the link at the end of this video to check out his work. This is Earth. Every human being that's ever lived has called it home. A seemingly lone bastion of life in an otherwise barren universe, Earth is something very special. Despite our best efforts, we've never detected any form of life beyond our pale blue dot. Why is that? What attributes make planet Earth a better host for life than any other celestial body? First and foremost, the presence of liquid water. Based on our current understanding, liquid water is a prerequisite for life as we know it. Thanks to a number of crucial factors not present on other planets, Earth is perfectly suited for water. The primary factor we're going to consider is the Earth's location relative to the Sun. Our little blue planet resides in what's called the habitable zone, which is the range of orbits around a star within which a planet can support liquid water, given sufficient atmospheric pressure. This limited band is often aptly referred to as the Goldilocks zone. Any closer to the star and the planet is too hot, any further and it's too cold. Luckily for us, the planet Earth sits comfortably within the habitable zone of our Sun. Because of this prime galactic real estate, Earth has played host to a dazzling array of life forms, from single cells all the way to incredibly complex beings. You might be thinking, with all the billions of other planets out there, surely Earth can't be the only one so perfect for life, can it? On February 22, 2017, NASA held a press conference to reveal some very exciting news. This is Trappist-1. It's an ultra-cool dwarf star, about 40 light-years away in the Aquarius constellation. Astronomers first discovered 3 Earth-sized planets orbiting the small star back in 2015. NASA's exciting announcement? Not only did they discover 4 new exoplanets, bringing the total to 7, but 3 of those planets fall well within the habitable zone of Trappist-1. Let's take a look at the full roster. Here they are, in all their glory. Trappist B, C, D, E, F, G, and H. Not exactly the most elegant names, but we'll make do for now. Part of what makes these planets so exciting is that they're all rocky, like Earth, and they all have a radius between 0.75 and 1.08 times that of Earth. Of these 7 planets, E, F, and G orbit within the habitable zone. This habitable zone is quite different from that of our own Sun, as Trappist is significantly dimmer and less powerful. This means that even though all 7 planets orbit closer to their star than Mercury orbits the Sun, the comparatively mild radiation from Trappist still allows for potential liquid water. As exciting as that possibility is, it's important to note that these planets are suspected to be tidally locked. When a celestial body is tidally locked, it always faces the same direction, much like the Earth's moon. That means that one side of each planet receives all the radiation from Trappist, and the other side remains in perpetual darkness. Since Trappist-1 is so relatively mild a star, it's not yet certain whether its planets would suffer from extreme heat on one hemisphere and extreme cold on the other. However, even if that is the case, it's thought that a proper atmosphere on any of these planets would help dissipate the heat and allow for a milder climate. As fascinating as the discovery itself is, what's equally fascinating is considering what life would be like on a Trappist planet. What would it be like to stand on the surface? One of the first things you would notice is that the light is significantly dimmer on Trappist planets. Since Trappist-1 is an ultra-cool dwarf star, most of its radiation is in the form of infrared wavelengths rather than visible wavelengths. According to NASA's report, the day side of Trappist planets would never get brighter than Earth's skies just after sunset. Once you got used to this perpetual twilight and looked out into space, you would see something remarkable. From any given Trappist planet, you would be able to see most of your planetary neighbors drifting across the sky. And they wouldn't be tiny specks of light like Mars is to us. From a Trappist world, you'd be able to see the texture on your neighbor planets, much like we can see the craters on the moon. Think about it. Someday far into the future, residents of one planet could look up into space and see the crisscrossing lights of civilization on their neighboring planet. Imagine one day a child is born on Trappist F. Since these exoplanets are so close to their star, it takes them almost no time at all to complete their orbit. That means that on Trappist F, little Johnny will be celebrating his birthday every 9 days. As of right now, we can't see the Trappist planets directly to get detailed findings on what their terrain or atmospheres are like. Luckily, with the James Webb Telescope launching in 2018, astronomers will be able to more accurately determine the chemical makeup of each planet's atmosphere. Newer telescopes like the James Webb will be able to assess the greenhouse gas content of the atmospheres and give scientists a better understanding of surface conditions on the planets. The ideal scenario would be discovering the presence of what are referred to as biosignatures, such as methane or ozone. The presence of such biosignatures would be a strong indication of past or present life. The star itself is classified as an M dwarf star. This is extremely promising for the possibility of life. An M-dwarf star is known for burning very slowly and at very low temperatures, the lowest of any other type of star. This means that they can burn for up to trillions of years, unlike larger, hotter stars like our Sun, which have a lifespan measured in billions or tens of billions of years. What does that mean for the possibility of life? Well, if TRAPPIST-1 has been providing warmth to its planets for such a vast amount of time, that means life has had ample opportunity to emerge, or even develop into more complex forms. If life is actually discovered in the TRAPPIST system, it bodes well for the existence of life elsewhere in the universe. Not only because we would have found one example of it, but because M-dwarf stars are among the most plentiful varieties of star. With billions of M-dwarf stars in the universe, providing warmth to billions of planets over incalculable stretches of time, just imagine the potential for life out there among the stars. With the launch of the James Webb Telescope fast approaching, we're in for a very exciting next few years. Imagine the significance of discovering life in the TRAPPIST-1 system. Not only would the great question of "are we alone" finally be answered, but the discoveries we make on the TRAPPIST planets would dramatically increase our understanding of habitable planets, and pave the way to greater and more frequent discoveries in the future. Who knows? Maybe the discoveries we make in the next few years will lead us to the greatest discovery of all, a planet just as suitable to life as Earth. It's all incredibly exciting, and TRAPPIST-1 is just the beginning. These 7 exoplanets are just a tiny fraction of the confirmed number outside our solar system. Many of them are far stranger and more exotic than the worlds of TRAPPIST-1. You can learn more about the amazing variety of planets in the universe by checking out this video by Real Life Lore, where he explores the incredible things you could see and do that would be impossible on Earth. Thanks for watching, and I'll see you in the next video.